Okay, for Tuesday, 9 Math 3, get out your ACT packet, and they did problems 24 and 25. Just pause this, then come back and you can check your answer. Okay, it says, what is the tangent of B? That means you need to circle B. Label your triangle according to SOHCAHTOA. Remember that? Sine is opposite over adjacent, cosine is adjacent over opposite, and tangent is opposite over adjacent. So label your triangle. Opposite side, adjacent side, hypotenuse. So the tangent of B is opposite over adjacent, which is C over A, which is J. And then here we have a chord that's 8, and we're wanting to know the radius of the circle. So from here to here. When a chord and a radius intersect at 90 degrees, it divides that chord into 2 equal pieces. So this is 4. So just do Pythagorean theorem, 3 squared plus 4 squared equals r squared. So r is 5. Okay, let's see. We did this yesterday, and I'm pretty sure this is what we did, but let me go ahead and fill this in. Y equals x cubed. You need to graph it, plot your points. If you don't know how to do this, look at yesterday's video, and it will explain this. 8, -8, -1, 0, 1, and 8. So -1, -1, 1, 1, 2, -8, and -2, -8. Okay, and here's our function. The domain, all real numbers, which means negative infinity to positive infinity. Same thing for the range. There are no restrictions. X-intercept and Y-intercept for the parent function, 0, 0. Maximum number of roots. Remember, it comes from right there. That tells us how many roots we need, and there are 3. In behavior, it's always going to be as x approaches positive infinity and x approaches negative infinity. So if I'm putting in x's going in this direction, I can see that my y's are approaching positive infinity because they're going up. And if I'm putting in x's going in this direction, my y's are falling, so it is going towards negative infinity. Quartic, it just means y is equal to x to the 4th. And again, you can graph this in your calculator, and you will be able to get this table of values because you graph it, then you go to second graph or second table, I forget which one it is, and you will get this. Okay, we're going to choose the same points. The reason I'm choosing these is because when I look here, it's easy just to go from 1, 2, 3, 4, 5. -2 to the 4th power is going to be 16. That's 1, that's 0, that's 1, and that's 16. Again, I get this from my calculator or by plugging in. So 1, 1, 2, and 16. And I really wish that you would graph this one because it shows you, it looks very much like a quadratic, but it gets very flat right there, and then it goes on up. So that's just a rough sketch. No restriction in the domain. Range from 0 to positive infinity. The x and y intercepts are the same. Maximum number of roots is 4. As it approaches both of those, it is going to positive infinity for both. Okay. Here, this is just saying a to the n. What is this called? This is like a standard form of a function, and that is our leading coefficient. So you put in standard form, remember that's in decreasing exponential order, decreasing exponents order. And the largest exponent's coefficient is known as the leading coefficient. So here we are wanting to find the degree. This is x to the 0 because anything to the 0 power is 1, so it has a 0 degree, and the leading coefficient is 4. For this one, look at the first term. What is the exponent? It's 1, so it's a 1 degree function. It's a linear function, and the leading coefficient is -5. Why don't y'all pause this now, finish doing this, and then come back and check. Has a degree of 2. The leading coefficient is 12. This has a degree of 3, a leading coefficient of -1. This has a degree of 4, a leading coefficient of -3, and this has a degree of 5 and a leading coefficient of 9. That's all we're looking at. Here, let's fill these in and just sketch the graph. Remember, this is the one that we said was a little flat there. Linear, y equals x. Quadratic, y equals x squared. And cubic, y equals x cubed. Okay, these are even degree, 4 and 2. These are odd degree. And what I want you to see is this. Look at their end behavior. When you have an even degree function, it ends in the same direction. Ends in the same direction. Always. And then an odd degree, what happens with the odd degrees? Starts in one direction, ends in the other. So these end in opposite directions. I hope that makes sense to y'all. If it's an even degree, they're either both going to be ending going up or going down, because remember, it could be a negative leading coefficient. For an odd degree, they're going to go in different directions. Start at the bottom, end at the top, or start at the top and end at the bottom. Okay, that's all that we did for today.